give a situation, then you decide whether it's Q&A or Q&E or Q&E. You know what I mean? Okay? So remember this one. Now, electromagnetic wave is important because this is the major propagation medium that we use for what? Ranging. Okay? Ranging is a very, what you call a fundamental principle of measuring what? Distances. Okay, let's call ranging. Okay. So how do you do ranging? Use electromagnetic wave, and what do you use? Speed of light. Okay? What's the speed of light? 3 times 10 to the power 8 meters per second. Okay? So that becomes the fundamental element. That means 1 millilight second equal to 300 kilometers. 1 micro light second is 300 meters. So this is a basic building block of all ranging systems. Therefore, you have to understand the property of and propagation of electromagnetic wave. Okay, very important. Now, in navigation, we are interested in accuracy. Actually, you are interested in inaccuracy, so that what are the errors. Okay. Once you define the error, we know how to correct it. Or we can live with it. There's certain error we can't correct, but we live with it. Okay? So the other thing is the limitation. For example, if you are using VHF, VOR, all these are VHF, okay? You have limited by what? What is this formula here? What is this formula? Anybody know? What does this formula represent?
The line of sight.
Line of sight, okay? So you have to know that you're limited by LOS. Okay, you may be asked to calculate LOS under certain circumstances. Okay, right. So here the various. Of course, compass is not very important. I don't think I'll ask you anything about compass. Okay, it's complicated and just very hardly used at all. Okay. So here, ADF, VOR. Okay, these are the two basic terrestrial navigation systems. Okay. There are, of course, have this thing like called hyperbolic, okay? Hardly used. Hyperbolic, Lorentz, all these things are hardly used. Okay. So as I say, most unlikely I won't. So I will probably focus on the important thing like this. What's the other important thing about terrestrial navigation system? ILS, okay? Very important. Instrument landing system, okay? Somewhere to the instrument landing is very important, okay? So these are the kind of things that you should expect from us. Now this is this one. The next slide will show you what it is. Okay. Okay, this is the next slide. Okay, what happened is you see this thing called the DR computer. What's the meaning of DR? Dead reckoning. Okay, which means basically ranging. And what does it make use of? Two fundamental. I always go for the fundamental. What are the fundamental elements of DR? Speed and time. Okay. Right. So this is straightforward. So anything that means of speed and time is a DR. INS is an example. Like inertial navigation system, sometimes called IRS. It's basically using the speed of what I call integration. It's a DR. That means velocity. How do you get velocity? By integrating acceleration. You see here it's not use ranging anymore. It uses its own acceleration. You integrate the acceleration, you get velocity. You integrate one more time, what do you get? Distance. Okay? So from there, it's DR. DR means from a basic position, you predict the next position by knowing the velocity and the time. Okay? DR. Okay, simple. So this one you don't worry about it, nobody else. These are important things like position. VOR, DME, Lorentz, and GPS. Okay, just remember, VOR does not give you position. How does VOR derive position? More than one VOR station can give you position by triangulation. Okay, so in itself, VOR does not provide position. They provide only bearing information. VOR and ADF only provide bearing information. It doesn't provide. So you need to integrate 2 or 3. Or you can use the DME to give you position. Okay? So this is what I mean by all this information. Of course, GPS gives you position straight away, 3-dimensional. Okay? All this will go into this thing called the most probable computation, which is what I call area net. Okay. I will not be asking you a question on area net because that's quite complicated. A lot of these things I talk actually many hours. I just integrate it into 1 or 2 hours. So I don't expect you to know the details of that. Okay, this is just a quick map of that. Okay, now I also mentioned about gyro. This is a very, very interesting technology. You should know about it. But I will not ask you a question about this. These are quite complicated and it's hardly used. Okay. Same, the magnetic field. For this, I'll probably ignore because there are a lot of things in the computation of magnetic fields and all that. Okay. But they're hardly used today. Okay. See this INS, right? Basically, you have what you call the IMU, right? The accelerometer, the key thing, accelerometer and gyroscope. Okay. So accelerometer give you, as I say, accelerometer integrate time, we get velocity. Integrate one more time, you get distance. Okay. For gyro, angular velocity integrate into angular displacement. Okay. Straightforward. Okay. Now I will not be asking you a lot of details on this, but I need to know roughly what are the problems with INS. Advantages and disadvantages. That's all I need you to know. Okay. Right. Okay. So here, these are INS system used on the aircraft. I will not be asking you system on the aircraft because this is type course. If you do the 147 exam, they will ask you the SLCC. They will ask you all this. But for our course, I will not ask you what is happening on the aircraft. Although I told you about it. Okay. Right. So I need to tell you all the display of these things. You don't have to worry about that. Okay. For example, this is a system of the aircraft. Right? When you go to work, you can connect, but for this purpose of this exam, I won't ask you this. Okay? Right? So all these things I won't ask you. Okay? But the principle I will ask you, right, how the INS and what are the problems with INS, right? Maybe it's about MEMS as well. Okay? Alignment, complicated process. Don't worry, I won't ask you about these things. Okay, on the gyro, gimbal system, step down system, right? The IRS is the same as the INS, except the fundamental measurement is different. What does it measure? That they use this, so I don't ask you about this thing, you don't worry about that, okay? This is the one I've done, okay? What principle is it used on? It's called the Segnet principle, okay? Which is that if you send two beams out, like if there's no rotation, the two beams will arrive at the same time. So when they arrive at the same time, there's no interference here. Okay, this interference pattern tells you that the two beams do not arrive at the same time. Either it's a phase difference or frequency difference. Okay, when there's a rotation, one path is shorter than the other, so they'll arrive very, very minute differences. Don't forget, these are laser lights. Okay, this is called the Segnet principle. Okay. So for this system, we need to know what are the problems. Integration drift is the biggest problem for DR system because it continues, the error can snowballing. So that is one problem. Okay. So this is the standard for INS and IRS is 0.6 nautical miles per hour. That means you fly 10 hours, you will be up by 6 nautical miles, which is not acceptable in law of navigation system. Okay, so INS is a long-term system, but the error integrates. So normally you combine with another system to zero down the error whenever there's an opportunity. What system do you use? DME was the earlier system. Today we use GPS. That means once you know your position, you press the button, you zero the error. Is it? So INS and IRS kind of fall into the same problem. Okay. Now here we talk estimation common filtering, which is more range RNF. Okay, so I don't ask you about this. Okay. So you know what the advantages you have to know. That is immune to jamming. Okay, used for military purposes. Okay. Disadvantage is very expensive. Operating cost is high, very heavy. High power requirement. This one may be out of date because today INS are built into MEMS. You know what is MEMS like? The electromechanical system, just in the chip. So today you can buy INS together with a GPS receiver, this size, this like a matchbox. cost about $6,000. Okay, but the weight and size has gone down tremendously now. Okay. Okay, I mentioned to you hyperbolic. This is an interesting system. I probably wouldn't bother to ask you because these are quite complicated system, but hardly used today. Okay, okay, hyperbolic again. Okay. This is another thing, the Doppler navigation. Doppler is the phenomenon, natural phenomenon that occurs everywhere in transmission of radio. Okay. But this particular case, the big use of Doppler as the primary tool, and it's very difficult to measure. There are a lot of disadvantages with this system. Among them, the antenna is very big and very heavy. So this is also hardly used. You just got to know it exists. Unlikely I'll ask you a question about the Doppler navigation system. The Doppler effect, yes. Doppler effect has been used for other purposes. For example, in the VOR, it's used to tell you whether you're going towards the station or away from the station. Okay? But in the radar system, they used to detect whether the clouds has got water moving, the speed of the turbulence. Okay, that's called what I call a Doppler radar. Okay, so they are used for auxiliary purposes, not the main navigation. In this case, they were using it for main navigation, which is not used today anymore. Okay, right. So among the terrestrial navigation system, we have the ADF, right? They use the loop to sense the direction of the beacon. Very straightforward. Okay. It doesn't transmit anything, it just receive and say, I know your station is there. And because the station has an ID, from the map you know the station's lat long, and if you know where's the bearing, you can, but in itself it cannot tell you where you are, because you don't know the distance. So you need 2 or 3 to triangulate to get. Like, so these are all geometrical tricks. Okay, so because this is a map, like you see, the one this is like, but this is ambiguous. You get a maximum direction. You don't know whether the signal is coming from here or coming from there. So we put a sense antenna, and you can see by putting the sense antenna, it adds on to this loop. Okay, you can see here. Okay, therefore this one becomes a cardioid, so you know that the signal is really coming from here. Okay, very simple, clever geometrical trick, right? Do the ADF. So ADF is used today, but very short range. So in America, they use it a lot because there are a lot of radio stations. You don't have to set up an ADF station. A radio station is already an ADF. So in the past, a lot of those small aircraft uses ADF. But today, because GPS is so cheap, hardly anybody uses ADF. Okay. So this is what I call what kind of errors, right? You need to know the errors. Okay. And what this is talking about the instrumentation, your T models, right? Remember how you position all these things. So in the T configuration, ASI is on the left, altimeter is on the right, center is the ADI, here is the HSI, standard T configuration. These are potential questions I can ask you, okay? These are just don't worry about this transmission power, because there are more details about ADF system which we do not normally do, okay? VHF, very important, right? This is one of the most important VOR because it's been used for so many years. Right? So out of the 3 questions, it is likely I'll ask you at least 1 question of VOR. Okay? Because it's one of the most important. So I'm just explaining to you that for each subject, you only got 3 questions to ask. I only got 3 questions to ask you, okay? Not that I wanted more, but so you can imagine what are the main questions I would ask, okay? So this is the VOR station. How the principle, I'm interested in the principle, how it works, that's all, okay? And what signal it gives and what signal it receives, okay? The VOR only receive, and you only receive one piece of information, radial, and that information can tell you we're bearing to or from the station. It does not give you position, okay? It does not give anything except bearing, okay? So don't worry about this sub-frequency, all these things, these are for type cost people, okay? Right. So externally, you can see this is a beautiful diagram. Right? I may put a diagram there and ask you to interpret the diagram, okay? Quite easy, right? Okay. Now, DME is an interesting thing because DME is one of the simplest equipment on board. You just transmit the signal, interrogate, come back, minus 50 seconds or 50 milliseconds, and then you can tell how far the aircraft is from the ground. And normally it is integrated with what? The VOR. Remember, the VOR has only a bearing information. So VOR together with the DME can give you a lot of navigation. Now because you know the distance, is it? So this is how we add all these things up. Okay. And this is how they do, they interrogate and then they reply 50 milliseconds later. So this is how you calculate the time difference minus 50 milliseconds divided by 2 because it's two ways. You can tell the distance. So remember, 1 light millisecond is 161.8 nautical miles. Remember I told you 1 millisecond is 1 light millisecond is how many kilometers? 300 kilometers. Okay? Therefore 300 kilometers equal to 161.67 nautical miles. They are the same. Okay? They make 1 milli. So anybody know what is the distance of 1 light year?
1 year thing, no light travel.
Yeah, how far?
300 million times 365.
You can calculate. Okay, it's roughly about 6 trillion 6 trillion pounds. Roughly 6 trillion pounds transferred to kilometers. Okay, it's about 8 or 9 trillion. Okay, 1 light year. Okay. In astronomy, you use light year all the time. Millions of light years. You know, some of the stars are millions of light years away. Okay. Okay, for GPS, of course, this is a central system. Definitely, there will be at least one question on GPS. Okay. You see, interesting here. I tell you, I've got 3 questions in one subject. It's extremely unlikely I have a chance to ask you more than one question for any subject. So you can figure out what is the most important or 2 or 3 important subjects I will ask. Okay, these are quite simple. In fact, for all your exams, you should use this method. You try and figure out all these things, how we set. Okay? Then you don't have to go and spend time on some of the less important things. Okay, right? So you need to know a bit of the detail. Right? Don't worry about segments of this thing. I'm more interested in the. I'm not interested in this is the type of. I'm more interested in the operation. Okay, what is the principle of GPS? Like simply ranging. Okay. So you want to know the distance of one satellite, but fortunately we cannot do full ranging. Why? You cannot synchronize the clock. Therefore you use what we call pseudo ranging. Okay, you call it pseudo ranging. Okay, right. So very important. You must understand what is pseudo ranging and why you have to use pseudo ranging. Okay, and pseudo ranging makes it simple. It's called trilateration. That means 3 satellites can determine the point, 3-dimensional space. It's called trilateration. But because you cannot get the exact ranging, you have an error. Okay? So the trilateration will end up in an error. Okay? So by using a clever mathematical trick, like you set a fictitious delta t, which is equal. All of them are equal. You assume that the 3 satellites, the errors are the same. Okay. So because you have the delta t, you add one more dimension of the equation. You need another satellite to remove that equation. Okay. This is how pseudo ranging, how the principle works. Trilateration. This is not triangulation. This is trilateration. Okay. Okay, these are simple and all some of the errors here and there. Okay. Right. Remember, this is how range error. Okay. And of course, here are the what I call the position DOP. 2 satellites very close will give you bigger error. 2 satellites very far away give you smaller error. Okay. This geometry you can escape. Okay. Okay, I will not ask you about RNF, but it's interesting to know RNF. It's a new concept of using many navigation systems to arrive at the usable specification for radio. It's not radio, R is area navigation. Okay, so this is the principle of area navigation. I will not ask you this because these are quite detailed. Okay? So means all this equipment. Okay, common filters, okay, and RNT related to RNF, okay. Okay, I will ask you this question. Okay, so this is the end for radio navigation. Any questions? Okay? No. No question. Ready for exam? Okay, I'm going to go to the next chapter now. Okay.
How you all do the build up? The 3 to 15. Thank you.
Okay, now we look at the FMS. Are you ready? Okay. So you pay attention to what I tell you what I don't ask, but I don't tell you what I'm going to ask.
Yes. How you get visual? Because if okay, it's 10K, right? So you use this, the other one is different. So can be either one or can be either one. I don't think there is any difference. Okay. I think the only way is to
Okay.
yes.
Ready for next part?
Yes. Let's go.
Go. Let me take a time.
You make sure that it is fully placed and the crest first. Crest first.
No, but it's not what the slides give you, right? The notes. Because the notes is from gradual 3 volts to 3 volts.
Oh, you're talking about that?
The waveform.
Then you won't get it.
Why?
It's only this one.
Why?
No, it's not give you one.
I thought you will give that one the gradual 3 to 15. Why? Why cannot?
Okay, now we go to the second aircraft system.
You see the
I get what you mean.
Okay, we're going to look at FMS. Fly by wire, pilot ECAS. Okay? Ready or not?
yes. Let's go. Your thing you get the same value. What's the deviation?
I got 4.9. I got 4.9.
But calculation got how much?
Oh, I got two computers.
Huh? But you calculate also got different.
Wow. Very heavy, right?
I'm not sure how to get that one.
Carry one also, I didn't hear.
Oh, sorry. I think I get what you
Okay, ready? Let's talk about FMS, okay? I won't be asking you question about this kind of thing. Okay, like this, I explain to you that this is operation. Why I'm asking question?
Yeah, why not? At the end of the day, all
This is important.
okay.
Like 4 functions of FMS. Okay?
I think we'll save on. Yeah.
Like what information they receive. Okay, this is from where. Okay, these are important information here, you know. Okay, and what's uploaded data? Okay, what kind of data? Very basic. Okay, and here don't forget this is a task. Tasks are different from function. What is the difference between task and function? Function is the objective. What's the output? Task is the input. What are you doing to get the output? Okay, so there are 2 different things. Okay, so these are the functions. Right? This is what they are doing to do something. Right? This is what are the things they are doing to reach there. Okay, so these are the tasks. Very important. You got to know this because that's a basic of the type management. Okay. Okay, these are slightly less important things like what are the modes, there are 4 modes here, obviously, like take off, flag, cruise, and all that. And this is interesting. The strategic mode. Okay? You either fly fast or you fly slow. You fly slower, not so slow. You optimize to get a fuel, that means minimum fuel, or you fly to minimum time. But most of the time you go in between. Econ. Like I explained to you, econ means you have to take care of time. Sometimes does not manage money. Okay? Right. Okay, so system monitoring, alright, very important. All computer system needs monitoring. That means they got to monitor themselves, they got to check the data. Okay, very important. Okay, as I mentioned, in the past there were 5 people, now there will be 2. Okay? And don't worry about this one, this is just a time course. We will talk normally about what the database, what it's used for. Okay. Right. This is the same thing, how the components are linked up to the FMS. Right. Well, this picture is more interesting, it's the same thing, but it's more graphic. Okay, okay. More graphic, okay? Right? Okay, so that's when the profile is like this, you take off, cruise, approach, landing. Okay, 4 different modes of operation. Just a detail of how the landing, okay, quite complicated. And this is on cruise, okay? This is an intervention, right? Whenever they see a cloud, they can actually change. Right? Okay? And this is a basic function of the flight. Okay. Now you do an autopilot. What's the first function of autopilot? Stabilize the aircraft. After that, keep it in the same altitude. Okay. Right. After that, they learn how to navigate. Okay. And after that, they learn how to land. So they're very ambitious in a sense. Okay. So this is what autopilot does. Okay. Integrate navigation and all that. Okay. The important thing is the landing. Okay? So there will be questions asked on the landing system. Okay? Cat-3 landing. Right? What is the meaning? What are the requirements? Okay? Of Cat-3 landing, designed for safety. What's the meaning of flight of fail up and fail blessing? Okay? So these are the design philosophy. Okay, so this is what's the meaning of when can you use the fail? We want to do a complete auto landing, you have no decision height. That means the aircraft can actually touch down. If you want to do that, you need to have a failed operational system. That means there are the 3 autopilot operating. Then it can do a touchdown. Okay. Because 3 system means they monitor each other continuously. And if one of them is up, they move it up so it doesn't interfere the landing. Okay? Whereas if you have a DH of 50 feet, that means at 50 feet the pilot has to take over to land. Okay. Now, under that circumstances, you need to have a field passive system. You don't have to have a field operation system. That means if one of them fails, must not interfere with the other. This is called field passive. Okay. So the philosophy of autopilot. And what are the importance of fly by wire? These are very important. Okay, you got to know them. Okay. So fly by wire, this is a diagram of how it does. Okay, you have the control here. Like there's no direct mechanical connection to the air. All control surfaces are driven by what? Hydraulic. Okay, they are all driven by hydraulic. So you got PCU is driven by hydraulic. The signal that comes in are electrical. Okay, so this one fly by wire is what? Electrical, is hydromechanical. Okay. A bit more complicated is the 777 auto pilot system. Okay? It's got 3 buses to make redundancy. Okay? And this primary computer, private computer, and this ACU, they talk to each other continuously before they send an analog signal to the power control unit. And then here are all the computers that are linked to this. This is a 777 fly-by-wire system. Okay? Right. Now on the A320 it's very different. They have this thing called control law. Right? Primary control law using that means elevator and ailerons. Okay, here ailerons and elevator. Now if this fails, they go into a secondary control which uses like SEC, spoilers. They use spoilers and elevator. Okay, they do not use aileron when this fails. So it's in. Okay. So this one they duplicate it. Okay, FAC is just an augmentation computer. It doesn't fly the aircraft. And there's such thing as yaw damper and rather trim limit. This is the okay. This is just a basic operation of the autopilot device. Okay. Now they have this thing called redundancy control, pitch control, normal law, control by elect, alternate, this, okay, direct control, there's actually a pitch trim. Notice it doesn't go to the elevator. Where does it go? There's a mechanical, like one last mechanical trim. Goes to the horizontal stabilizer. Okay, it's a trimming system. Okay. Okay, now we look at DEIS, right? Okay, DEIS system, this is how, don't worry about all these boxes, right? Okay. So the DEIS is quite complicated. I may ask you one question, I think out of 3 I can only ask you one question, okay? I may not even ask because it's quite complicated, okay? Okay, now let's say I don't ask you a question.
Who say that?
This system is a type course question. Okay, so I just want to let you know this thing happened, but there's no point asking all the details. Okay? But those who are presenting, you better know. Okay, so you have a question, you better ask me now, okay? Yes. Sometimes, so this is what happened. The most important thing is this: you need to know the ATC, Air Traffic Control Transponder. Okay, ATC on the ground is called Air Traffic Controller, not the same. It's a man, person. Okay. So when you talk ATC transponder, it's transpond either A, B, AC or S. Okay. Right. So on mode C, you will get altitude information. Okay. Mode A, you only get the squawk information. Okay. See, this is how it looks like. Okay, the range ring. Okay. On the mode A and C, this is how they interrogate. They measure by the seconds between pulse A and T1 and T3. If it's 8 microseconds, then it is mode A. But if it's 21 microseconds, then it is mode C. Pulse B is a control. It's not transmitted by the main beam. It's transmitted by another antenna. Okay, let's explain to you what this do. Okay, so these are the pulses that I go through. I went through already, right? Remember I went through this, okay? Right. So mode A, 8 microsecond between pulse 1 and pulse 3, okay? Mode C, 21. Mode S, 3.5 microsecond, okay? Okay, here I don't want to go through it. I just went through this. Very simply, antenna do have side lobes. This is called side lobes. So they purposely put another antenna to produce a P2. This is a control P, okay? So the control P signal is stronger than the side lobe. So say aircraft A here will receive this, P1 very high, P2 very low. That means they know it's a correct one, okay? In the main lobe, okay? But if the aircraft is here, right, the P2 is higher than the signal, so this aircraft will not respond. This aircraft will not respond. So it's kind of a side lobe suppression system. It does not suppress the side lobe. It tricks the aircraft using this simple trick to tell the aircraft don't respond. You see? The side lobe, it can't help you, you always have. Okay? Now on the S mode, we actually make use of this trick. We purposely put a P2 stronger than the P1, and it's transmitted in the main lobe. So that all the aircraft, when you receive this P2 higher than that, will not respond. Only the particular aircraft that is interrogated will respond. You see? So it's a different way of operation. It's a very clever system to make use of the P2 to interrogate. Mode S be selective. They select each aircraft. Whereas mode A and B is broadcast, it just said everybody will respond. Okay? Right. So now we talk about DEIS. As I say, it's a very complicated system. I won't ask you about this because I'll tell you how. It's a very simple system if you look. Right? Internally, it's just that you know. Okay? Don't have to worry about it. So DEIS is actually a simple air traffic control in the aircraft. So they broadcast information. Notice 1030 or 1 gigahertz. Okay. So here there was a question about this maneuver. See, in the first intent in DEIS, there's this thing called the resolution, traffic advisory and resolution advisory. Resolution is to tell you what to do. Traffic, they can tell you there is an aircraft there. Okay. So here's a problem, there's a conflict and all these things, okay? Like, this is how you measure the distance. Notice they measure by how many seconds, right? They didn't measure by distance because the variable speeds. Right? Now this is what they call revision 7 and 7.1. Okay? In the past, there's no reversion. DCAS can ask you to go down, but the other aircraft is not equipped with DCAS. The guy may also fly down because this guy has no DCAS. If you don't have an mode S transform, no DCAS, right, he won't be able to respond. Okay. So in the past, this descent has no reversion. In the new system, when they see this aircraft coming down, they can actually change direction. So that's why it's bad. Okay. The other thing about 7.0 is in the past, like if the DCAS system sense that there's a conflict, this guy is flying here, there's a potential conflict, they give you a choice of whether your ascent rate and the descent rate. Okay, you are ascending at this rate, you can continue like on this, or you flatten. Okay. Now, in the new 7.1, they program all this, no choice for the captain, the system are requested to flatten. These are actually choices for the captain to do. Okay. Now, they do give them a choice, okay? I think they must have crashed a few aircraft, make wrong choice. They get rid of the choice. Okay, so this is how the DCAS system go. Okay, so this upgrade and all that. Okay, so that's the DCAS system. Now I want to go now to do a little bit on the aircraft system, information system. 160.8884. Okay, today now we need to talk about the ACAS and the CMC. Now ACAS became a very popular subject. What happened during the MH370? Okay. The MH370, everybody asked a question, what is the ACAS doing? Right? They didn't know where the aircraft was. Because ACAS is a system that allows the aircraft to transmit data to the ground. Okay? Now the problem is that they use VHF. VHF means what? Range limited. Okay, so Singapore, as an airline, you cannot reach between about 300 to 400 nautical miles. Okay? So this ACAS guy is very smart. Okay? He set up VHF stations all over the world, and then he collect all the information. See, and this is I show you what it meant. Okay, so there's the demand mode, and demand mode means the crew call. The pole means the ground call. Okay, so this is what they do. See the system, right? ACAS system, okay, VHF. Now most aircraft has got 3 VHF. 1 and 2 is meant for the captain and the co-pilot. The third one is used for emergency as well as all other functions. So you will use a VHF 3. Okay, this is how what they do. Okay, they have a transmission network everywhere in the world that receives the transmission that goes into this company set up a transmission network and send it to the airline computer system. That means you subscribe to ACAS, they will receive for you and consolidate and send to you. Okay? And they can send to passenger service, flight operations, or maintenance. So if there's a defect you want to know, they send to maintenance. Right? If there's something wrong with the crew, they send to flight operation. Or they'll say, there's a storm coming up somewhere, or there's a volcanic eruption somewhere here, please don't come this way. You know? These are operational. Okay? passenger services, catering, all these things can be done through. So ACAS was very useful because we send data in advance. Okay? So this company is very smart. He collect all over the world and use transmission sent to the airline. Today, do we need that? No, because anybody can put it on the internet and send everywhere. So to some extent, this network transmission system is irrelevant today. Okay? The airline send email straight away down to their company computer. Okay? So this was actually, interestingly, this guy created this before we have internet. Today the internet does the job for us. Don't need this anymore. To some extent it's like that, okay? Now the other thing is that ACAS when it's out of VHF range can use SATCOM. Okay? Right. But it's very expensive. So people do not use SATCOM full time. Occasionally they will use it. So that's the reason why MH370, everybody think ACAS is on, but it's not. Because you do not switch on the SATCOM all the time, it's too expensive. Is it? Okay, ACAS management unit, flight data, okay. This is very, I want to ask you this aircraft system, okay? This is a flight data acquisition here, aircraft system, feed it to the ACAS, then it's sent by VHF com, or send it to the display unit, and then this is the printer. This is the actual system of the aircraft. So the ACAS is actually quite ancient, right? By today's standard, it doesn't look very useful, okay? Now another system is called the ICAS, okay? It's more important. ICAS and ECAM are the onboard monitoring system, okay? So ICAS are upper and lower, okay? Secondary display, okay? Okay, so computer 1, computer 2, and these are the information that provide engine display and secondary status. This one is more on status display, this one is more on primary display. What the primary display for engine? RPM, people, EGT, sometimes oil pressure. Okay, these are the N1, N2, all these primary display. Okay. Secondary display or static or other things is oil pressure normally comes as secondary display. Okay. Right. Now they also provide caution. Okay, red one is warning. Warning normally comes with an oral warning. Okay. Caution is just a light. Okay. Right. Okay, on the Airbus we use ECAM instead of ICAS. Same thing, 1, 2, 3, 4 display. This is ECAM 1, ECAM 2. Okay, this is the area. And the upper, lower, the same thing. They provide primary display here and secondary display here. Okay, this is the schematic. Okay, so you can see EADI, ESHI, the same thing. Okay. Now these are controlled by 3 DMC, right? Like the display, they call display the management system, okay, computer. Okay. And you'll see that one DMC want to supply information to here, DMC 2 to here, DMC 3 is standby. Anytime these two fail, they'll take over. Okay, very straightforward. Okay. Then they have this thing called flight management, flight warning computer. This is primary. Okay. They give oral warning. Okay, warning and caution. Okay. This is the what I call the equivalent of the flight data acquisition unit. They call it the data concentration unit. Okay, concentrator, system data concentrator. Okay, this is the tool. They take information from all these people. See, and this information is redistributed to DMC and all that. Okay. It's quite nice, quite a good diagram to when you're learning for the aircraft system. As I said, I won't ask you all these details because this is just a generic cost, not type cost. Okay. Now, most aircraft component has a byte. There's a button you press, and then you wait for a while. You go through the byte, and tell you green light, okay, red light, not okay. That's all. Okay, simple byte. Okay, most aircraft have it, but today, because the aircraft is very what I call complex. Right? So byte testing of few things you cannot. The operation test and maintenance test. Maintenance test cannot be done on board. It has to be done on the ground. Okay, this is the byte flow program standard. Okay, I won't ask you all these questions. So today I just want to let you know on the Boeing 747 you have this thing called the central maintenance computer, which integrates all the systems into one maintenance computer, okay, which is very useful. See, they got printers and everything. Although today is out of date. If you look at the 787 and the A350, they are much more sophisticated, where you can bring a laptop inside there, okay, and do your work. Okay? So this is a quick run through. Any questions?
Before that, all this.
Before we talk about your project. So your question okay lah?
Yeah.
Quite straightforward lah. Last time they give them more choices.
Divya.
Then this time they don't get
Divya.
They take away, they just say.
What do you include for your application?